Okay, so in this drill now we're asked to simplify each expression by rewriting it using sine and cosine. Your final answers should not contain fractions. So this is kind of like a tip for any trig identity. Rewriting it using sine and cosine is so that way you're trimming it from in terms of six different trig functions, right? Sine, cosine, tangent, cotangent, secant, and cosecant to just in terms of sine and cosine because all of those trig functions can be written in terms of sine and cosine. So in part A, we have tangent of alpha over secant of alpha, and we can rewrite that as sine of alpha. So we're writing the numerator, cosine of alpha, all over, and then secant is the same as 1 over cos of alpha. Okay, so dividing by 1 over cos, we can rewrite this complex fraction as sine alpha over cos alpha times cos. And then the cosines can cancel. So all of this fraction could just simplify to sine. All right, let's take a look at part B. So we have sine of alpha over cotan of alpha times secant of alpha. So again, sine of alpha, we'll keep it like that, divided by, actually, let me make a big division symbol. Big division bar divided by cos alpha over sine alpha. And then times secant is 1 over cos. So we just rewrote everything in terms of cosine, sine and cosine. All right. So so sine divided by cos over sine, we can rewrite it as sine alpha times sine alpha over cos, and then times 1 over cos alpha. So this eventually simplifies here to sine squared, because we can multiply sine times sine to give you sine squared, over, and then we're multiplying cosine times cosine, so we're going to have cosine squared. So we're not supposed to have fractions in our final answer, but sine squared over cosine squared, that's just tangent squared. Okay, so your final answer here, without any fractions, is just tangent squared. Part C, sine of x. And then I'm going to rewrite cotan as cosine x over sine x, and then times cos x. Okay, so we can multiply cosine times cosine in this second fraction here to give us cos squared. Over sine, and then this is going to give us, this is just still sine x. Erase that here. So still sine x. And we have to get an LCD, right? And then eventually combine our like terms. So this will give us sine squared, because we would have to multiply sine x to both numerator and denominator. So this will give us sine squared x over, and then we had to get a common denominator there, plus cos squared x over sine x. So now that we have a common denominator, we can actually just combine the terms of the numerator into one single fraction. So it's going to be sine squared plus cos squared, sine squared x plus cos squared x. But sine squared plus cos squared That's a Pythagorean identity. Sine squared plus cos squared, that's equal to 1. So we're replacing the whole numerator with just 1 over sine. And then 1 over sine is cosecant. Because, again, no fractions for our final answer. So our final answer, would, without any fractions, would just be cosecant x. And then finally, for part D, we have cosecant of t minus cos of t times cotan of t. So cosecant is going to be 1 over sine minus cos of t, and then we're going to multiply this times cos of t again. Cotan is the same as cosine over sine, so cos of t over sine t. So this is going to be 1 over sine t minus, and then we're multiplying that together. So we're actually going to make this cosine squared t over sine t. We already have a common denominator, so we can actually bring these values together. And then it's 1 minus cos squared t. And again, this is a Pythagorean identity. 1 minus cos squared, that's the same as sine squared. So it's going to be sine squared t over sine of t. So this means sine squared is technically sine times sine. So one of those terms can cancel out. So your final answer for part D should just be sine of t. All right. So this is kind of an introduction into the fundamental trig identities. And again, usually you want to keep everything in terms of sine and cosine.